All right. Still have a few things to get going with here. YouTube chat. Almost there.
Hey.
All right. Approaching ready. Getting there, as they say. All right. Now we're actually ready. The chats are there. Got the chats. Had the preview. This one? We don't need this one anymore. Oh, I said we don't need this one anymore. Okay. We switched this. I put the sound back on. Looks like we got that going. Okay. So good morning, everybody. Merry Christmas Eve for folks celebrating Christmas. Happy holidays. Happy New Year coming up. Happy Saturday. Good day to anybody else. I am Tim. My name is Tim. I go by Foamy Guy. I will be working on this morning on CircuitPython some pathfinding algorithms. If you're new to the stream or you're catching this in the future, though, you don't know what I am talking about when I say CircuitPython. Where did my browser with that stuff I was going to use go? Let's see here. This is over here. This is that one. Interesting. Okay. This is what we will use later. But like I was saying, for folks that might be new, generally speaking, what I work on the stream is CircuitPython stuff. This is the main website for that, circuitpython.org. You can learn more here. Basically, though, this is a version of Python that runs on tiny computers called microcontrollers. There's a bunch of pictures of them over here on the downloads page. In particular today, once I get to a microcontroller, I will be using this one, PyGamer. There are all different shapes and sizes of these devices, but basically it's a tiny computer that runs Python code In this case, it happens to be like a handheld game form factor device. So that is what we are working on generally on this stream, is all stuff related to these CircuitPython devices. In particular today, what I want to look at is Tilemap games, which is like a 2D style of game like this, where you have a grid, you have characters on the grid, or entities they're called specifically in this instance. The entities can move around the grid and interact with each other. Generally, this is a thing inside of games, video games. And that is what I would like to use it for, although, it could be used for other stuff as well, mapping actual physical spaces in the world or something, or, I don't know, stuff like traffic, generating traffic simulations or something like that. I don't know, it's not really a game, but it could use a similar technology. I'm interested in using it for games, specifically this kind of like top-down 2D grid system type game. This is kind of all way more in-depth than what we're going to get into today, though. Today I'm going to look at one specific aspect of the larger picture, which is a pathfinding algorithm. This is going to let us take a particular character. Let's add a Blinka to this, first of all. We don't have a Blinka. So let's say we have a particular character, Blinka, and we want Blinka to be able to move to somewhere else on the map. One way that this could be solved is give the user like a D-pad, give the player a D-pad, up, down, left, right. They press right and Blinka moves to the right by 1. They press right again, Blinka moves to the right again. Again, they move down, something like this, right? They push a button or they use a joystick or whatever. Character moves. The Pygamer even has a joystick on it, so this is a pretty viable option. But if you want to move a far distance, or if there are obstacles in the way, it gets kind of tedious, right? Sometimes moving one grid cell at a time is just kind of a slow thing, especially if you have lots of different characters to move or something like that. You don't always want to have to just go one space at a time using a D-pad, essentially giving an input for every action, right? Every movement action. What some games do, as an alternative to this, is let's say you want to move Blinka. Instead of pushing the buttons, one for each move, they'll have it to where the character controls, the user, I should say, the player controls like a crosshairs or a target cursor or something like this, where they can select a certain tile. And so the user could come over here and select, let's say, this tile where the heart is right now. The game will basically find a path between where Blinka is at and where the user selected and move, it can move the character there. So the algorithm that does that, finding the path from one spot to, one spot being wherever the character's at, the spot where the player has chosen to move to, generally this is called a pathfinding algorithm. A star is one of these algorithms, and that is what I hope to implement today inside of CircuitPython. How's it going, C. Grover? Good morning. I have implemented this once before in JavaScript. I followed this this person's tutorial, so shout out to this person, Arcade, on YouTube. I found their tutorial pretty easy to understand, as I recall it. I referenced this a lot when I implemented it the first time. I will probably reference it some now as well. It's worth noting, though, this is like HTML and JavaScript, and of course I'll be working in Python, but the general idea of the algorithm is the same no matter what language it is, and I happen to just have used this reference material before and liked it, so I will at least give it an attempt like this. If we get into trouble, if we get stuck somewhere, then maybe I'll search up like a Python implementation and we'll work from that instead, but that's kind of the goal. To start out with, we are going to kind of dumb it way down. First of all, I'm going to actually start working on the PC rather than on the microcontroller. So one of the things that we have is called the Blinka compatibility layer. This allows you to run essentially some code that is written kind of the same way you would write it for the microcontroller, but run it on in this case, my actual PC, my computer that I'm streaming from, my computer that I'm working on. It's meant for the Raspberry Pi, but it kind of works in this case as well. In particular, there's a pipeline to run display I/O stuff. So ultimately, this will run on the Pi Gamer, which I even have here. Let me pull up the camera just for a second. I do have the Pi Gamer set up. And eventually, I will want to work my way towards there. But we're going to be able to iterate even faster by just sticking onto my PC. So Pi Gamer is here. Ultimately, we'll have the joystick to control like a selector thing. We'll be able to tell the characters where to go. But, and this is all made with display I/O. This is essentially a tile grid with some logic built into some game map objects that allows this to render. And because display I/O can work with Blinka display I/O and we can run it on the PC, that is actually where I'm going to start because it's super quick and easy to iterate. CircuitPython is very quick and easy to iterate, but in my case, just running the script on the PC is even quicker and easier to iterate for something like this, because I basically am going to have to run the same program that's, not quite an algorithm yet over and over and over and over and over and over again until it is actually an algorithm and it works. And this will be much quicker, I should say, and easier to stream on the PC rather than bouncing back and forth to device. But the good news is the same code will work on the device once we're ready to move it to there. So right now, all I have is rendering the tile map, and this tile map in particular is the same one I have opened up here, although sans Blinka. Let me save it with Blinka. Run it one more time, and now we have Blinka there. So we already kind of have this pipeline set up of going from this tile map editor, this is a program called Tiled, into CircuitPython display I/O. If you're interested in that, there are prior streams where I worked on that and did some of the building the actual examples that I'm going to use here. And it is all in a repo on GitHub, although it's titled Tiled Game Experiments. It's not particularly officially published, but it is out there, the same code I'm using. I should probably clean it up and get it published more specifically, more officially, so to speak, rather than experimental thing. But that's where we're starting from, is the ability to render this tile map game, and we have Blinka in there. So I'm going to start just working on, I'm not even going to worry about the user inputting where we want Blinka to go. For now, I'm actually just going to start writing the function. The function is going to take the XY location. We're going to call the function. It's going to try to move Blinka to there. And that's really all we're going to worry about until that's working. Once that's working, we'll bring some user inputs and things in. I will want to go back to this one. And so some of this will be me kind of watching along with this because I need to rewrap my head around some of it. But then we'll be jumping back and forth between this and the code. Breadth first search, maybe we should start with that. Okay, so A star is more refined than breadth first. This is what he's explaining now. Breadth first is kind of like, you could see it in the way that it runs here. It's kind of just growing outwards in all directions kind of spiraling around, what it looked like to me. So it's like spiraling outwards from the red until it finds the path to where he clicked there. So this one kind of just grows in all directions indiscriminately until it finds the target location, and then it builds the path back from there. This is breadth first. A star is a little bit more refined. It's going to go more directly there somehow. Does he show it here? No. Interesting. Okay, that's a neat That's a neat. I never did get into implementing that portion of it, but that's a neat feature of this algorithm, which is that each tile type can have a cost to move past. So you can have tiles that are harder to pass than others. So like imagine, you have one tile that's a regular floor. It has no additional cost. It just takes one move to move onto it. But maybe if ohm is on the floor, maybe you can walk over it, but it takes, 2 moves or something instead of one. Or if you imagine like a forest versus a regular terrain or something like that. Okay. I will probably jump into some... Download the code. High resistance. Yeah, there you go. I like it. Okay, so there is, I'll pull up this page as well. There is on Wikipedia pseudocode of the algorithm, so we can actually reference some there as well. There's probably just a Python implementation somewhere we could steal, truthfully, but I'm interested in understanding it a little bit more than just adapting existing Python code. Because it will need to... Like, the existing code will probably be generic for a 2-dimensional plane. We'll need to adapt it some to work inside of the tile grid, ultimately, or the game map object, which is really what we have. Empire never stood still. Merry Christmas, Happy Holidays, everyone. Yeah, thank you, Dexter. Appreciate it. Merry Christmas to you as well. Bolt is just pushy. Nice. A star. We could have an A star on the tree, maybe. Top of the tree there. All right, so let's take a look through this for a minute. So reconstruct path came from current. Off of the bat, we'll have to say I'm not super sure about walrus operator, right? Something like this. What does it do? I think This is the one that I am more familiar with, I think, Python, but even being more familiar with it, I don't know what it does, top of my head. Okay, so get a variable, I assume none is the default, so if this doesn't exist, it's going to get none probably. If it is not none, then return it. Can now be walrus equals walrus equals none, so it's kind of like set it into here, but also check it for if it's truthy. But in this context, it's not a logic expression. Like, it's not inside of an if statement. I will look too. I have the JavaScript implementation that I made before. However, I did notice before I started streaming, it's not functional right now. I had started working on a different portion of the larger system and broken it, but there should still be the actual implementation in here, I think. Probably, so would it be inside game? Move entity. And this looks more general. New lock. This is just like teleport, basically. Find player. It's not going to be index. It's probably maybe going to be game. Can walk. Generate path. And there I ended up taking 2 points. Came from and current. Well, okay, no. Yeah, A star. They have start goal and they have H actually. What is H? Heuristic function. Estimates cost to reach each goal from node N. Not sure. Seems I did not necessarily use that in this implementation though. Got an empty queue, we got parent for sale, push the goal. Empty map. For node N, came from N is the node immediately preceding it on the cheapest path from start to currently known. So our queue starts with our target location. We then have a loop that says while the queue has anything inside of it, dequeue the first or last or whatever that does. Take one of the items from the queue out. It's a queue, right? So you should take from the beginning of it. Which side's the beginning? 0 index? I don't know. We'd have to look at JavaScript shift to know for sure whether we're taking from the front or the end. I don't know off the top of my head. We're getting a point off of it, though. Current key. So this is just a string that's making like X coordinate X the letter Y. So it's writing like, you know, if you had 3, 4, it's actually putting it into a string like 3x4 like this. 3 by 4 if you want to think of it that way. Which I think maybe is a quirk of, yeah, the implementation here, current key, it has it right there. That's very similar. And I think the way that the algorithm is implemented, it operates on that somewhere, but ultimately we'll turn it back into a point. It does have the point as well, though, current, which is the starting Is it? No, XY is what we, okay, XY is what we got from our point on the queue. So get all of the neighbors, get the 4 points surrounding the current point we're looking at. For each neighbor, we're going to loop over all of those neighbors. We're going to get the XY coordinate of each one. As we loop here, neighbor X, neighbor Y, ignore tiles outside the map, so we skip anything that's too far outside. Both of these accomplish that for us. One of them is outside left and right, one of them is outside top and bottom. Ignore tiles that can't be walked on, so if you're not allowed to walk on this tile, then it just, we ignore it. Same way we ignore ones that are outside the bounds. Key, so this creates another one of those strings, like that 3-4 I showed before. This one is the neighbor's location, though, instead of the current location that we are looking at, which is the one that came from our queue. That's the key. If it's not discovered, it's not discovered. So if the key is in the parent for cell, then continue. So continue is what we're doing when we are ignoring things here. This is basically saying, like, do we already have this cell in our list of cells to care about? If it is already in there, we don't need to add it again because it's the same cell. Like, we're eventually going to check it or whatever, but we don't need to check it twice or operate on it twice. So if it's already in the list we care about, then don't bother adding it again. And this is how we're doing that. Don't bother is just continue. So continue would just come back around and do the next neighbor. So if it is not already in that list, though, then we'll make it past here. So we'll go mark it as discovered, which means we're going to put it inside of this, which is that list of places that we've already, that we care about, places we're going to do something with. Generally speaking, I don't know more specifically. We'll get to there in a moment. Parent for cell, so we're adding it as a key. So that's one reason we're making it into a string, is because we're using it as dictionary key, which is kind of convenient for checking whether we already have it in our list or not, like this. So that's convenient, I guess. Key is the current key, which is current key. That's the one back here. That is the X string of the location we're currently looking at, the location we're considering. Not the neighbor location. That one's here. This is the neighbor location key. Probably we should call it neighbor key. But current key, this is like the coordinate within the algorithm that we're currently considering. It's the center of, it's the one whose neighbors we started checking. And then cell gets current, which is the actual object of XY. Just the XY coordinate as an object instead of a string. Mark it as discovered by putting it in there, and then add it to the queue, which is the queue that we are looping through back here from the beginning of this. I know it's much easier to visualize when you watch it run with like colored blocks and stuff like this, but it's pretty crazy. I don't quite, just reading through at least this portion of the code, it's crazy that this manages to like find a path. We'll have to visualize it at some point. So mark it as discovered, add it to the queue. So this is all we're doing in this portion of it. We're going through the queue that we started with our target location. So we started at our target location, we looked at its neighbors, we started adding them into the queue, as we added more things to the queue, we looked at all of those, that location's neighbors. We added more to the queue. We looked at that location's neighbors. We just kept looking at the neighbors, starting from the target location, moving outwards, ultimately. We're adding all that stuff to the queue. So when we get done with this, we're gonna have a bunch of stuff in here. Parent for cell. We're gonna have a bunch of stuff in here. It's all gonna be keyed with those strings. And then we're gonna basically use that data somehow to actually find the path. So that prints it out. We get an empty list ready to go to put our path into. We say current key is one of those strings again, and I don't know, I feel like we already made current key. Is this one actually different? We did make it here. This one was a const? Okay, no, this is making it each time in the loop. This one down here, though, this is making it for the XY that was passed. I assume that's like starting location. That's the location of our character. Should probably rename these things. There's current cell, so that's just the object representing the same point as that string. Print all of this stuff again. Oh no, print parent for cell, but then current key. Parent for cell, current key. Okay, interesting. So then that's going to be one of these objects, basically. So it's going to be pointing to the, it's going to be pointing back to the neighbor, the neighbor that we came from, basically. Okay, so they're saying parent as in like it's the cell that you came from. So like if Blinka starts here and then moves to the one next to it, while Blinka is here, the parent for this cell is the one we came from. That's what I think I'm understanding here. And that dictionary will essentially be a bunch of those that are always just pointing to wherever it came from, whatever the cell, whatever the previous cell was. It's almost like a linked list back to the previous one. In fact, it might just be a linked list back to the, I mean, we implement it as dictionary, but maybe it is actually just a linked list. I don't know. Generate path with connecting cells. So starting to generate path. That's awkward. Okay. If while not underscore is equal. Oh, okay, right. So this is a thing. Boy, that's going to be kind of quirky to solve in Python. Maybe we'll have to figure out how we're going to do that. This is kind of coming back to me a bit. This basically compares objects. I think in JavaScript, comparing objects. Think in JavaScript. Let's just say I think in JavaScript, and then the rest of the sentence, you know, you can fill in like a lot of different things. I think, though, off the top of my head, what I think is that this doesn't work as you might expect. Unexpected token colon. Colon, how you make objects? No? mean, I must be missing something super duper basic. Can I just not, I'm not just allowed to do it at the terminal? Is that the problem? I'm just not allowed to do it at the terminal like that. Okay, just not allowed to, like, I mean, a lot of, so like, speaking of the many things where you can just sigh and say Java, so I mean, like, if I just put a number, right, like 89, right, like, it just prints 89. 89 by itself is not a statement, but it does something. But apparently object by itself, it does this error instead of, like, just print the object, which is, I guess, what I assumed based on how it works with numbers and, like, strings. So, anyway, though, if you have an object and then you have another object, let's say it's the same to start with. These objects represent points in my situation. I accidentally did object again. So we have object and object one. Speaking of things you can just put here and press enter, right? So once you have it in a variable, you can just, like, put it here and it does its thing. So those two are the same. And, like, if you do this, object one equals, we could even do triple equals, object two, reference error, right, because that's actually object one and object. Get false. I was expecting flopping the order around to make it false, but you even get false directly. This thing, though, this underscore thing, which is where we started here, this actually, I think, allows this comparison to work. We can compare these two objects. It will tell us true if they are the same point, essentially, which is really what we care about. We don't care so much about JavaScript reference, instance, exact object, memory. I don't care really about any of that. We just want to know is it the same point, which is what this is doing for us. I think that's called Lodash. Lodash JavaScript library. Is equal. Yeah. I don't know in Python if we will have that problem or not. Can you compare dictionaries in Python and have it work? I mean, could we do tuples or something? We'll cross that bridge when we get to it. Really, we could just make a function that compares points, honestly. We could have it assume that the dictionaries are points and then just compare x and y on them. Worst case scenario, right? This is saying if x1 is x1, y1. Those are the target location. Yeah, target location. So if the target location is equal, but it's also not, so is not equal to the current cell. If the target location is not equal to the current cell, path.length. Path was our list object here. This is just going to print path length. If the path is too far away, return false. If we go back and forth too much, return false. Not sure what that part means. It sounds like maybe it gets confused and goes back and forth. I don't remember that being the case, but maybe. So path.length, if it's greater than 4, return false. This is basically limiting the amount of movement the character can have. Like, you know, you say character's only allowed to move 4 squares in a turn or something, right? This is the cap of that number of squares. If no parent, then we don't have a path. So if parent for cell current key is undefined, basically current key is undefined. I think this is roughly means like this key is not actually in this dictionary, right? That's what that would do in JavaScript, maybe, or else because I don't think we ever explicitly put undefined in there. So this is basically saying, like, is it not actually in there? So if there's no parent, then we don't have a path. We're just returning false. current key was the place where we are right now. For cell, current key is undefined, just return false. Why'd you go back and forth with A star? Why'd you go back and forth with A star? I'm not sure what you mean, Maestran. Why'd I go back and forth? Also, sorry, I'm not sure how long ago you mentioned that. If it was a while ago, I apologize. I'm still working on A star. This is just an implementation of A star. This is the JavaScript implementation. Happens to be the JavaScript implementation that I made while I was watching this tutorial the first time. And it's also the same. This is the pseudocode for the same algorithm. This is just my JavaScript implementation of it, which happens to be easier for me to understand because I wrote it. So probably I'll be referencing this some when we do the Python version as well here in a little bit. I know I've been mostly reading code for a minute, but we will get into writing code once I have kind of understood it. Wrote that when you were looking at the if we go back and forth too much. Ah, I see. Yeah, I don't know. I mean, I don't know why. Yeah. The truth is, I don't know what past Tim was thinking when he wrote this, truthfully. Yeah, the comment implies to me, to current Tim, that the algorithm will sometimes, like, it would consider back and forth like this over and over for some reason. I don't think that's the case. Current Tim sitting here now doesn't really think that's the case, so I don't know what past Tim could have seen that made him think that was necessary, but that's all we have to go off of now, basically. Where did this go? I want this back. There we go. Better. So this is just another return false. Basically, like if the path to that place was too long, then return false. If there isn't a path at all, then return false. Otherwise, if we get past those two checks, then we get to here. We say path.push current cell. We say const key cell. So this is just making one of these objects, basically, right? The same objects that we initially loaded into here. It's making another one of those. Const cell equals parent for cell that. So it's basically getting the object out of this is really more so what it's doing. It's getting the object back out of here. Not removing it from here, just accessing it. Getting a copy, I guess. I don't know. I don't know if it's a copy or if it's a reference or it's whatever, but it's getting that object out of there. Current key equals key. So current key is now going to change to the key that we got out of our parent. And then current cell, same thing, is going to change to the one that we got out of the parent. And then we are just looping around again, which means we start all the way back up here and check current cell, which is now the new one where we're at, the parent, essentially. Compare with target, do all the same checks. Eventually, the target will be the cell that we're on. This will then return true, which means we won't keep looping, which means we get to here, which means we finally print the path and return it. Whatever this stuff is. Okay. So that feels pretty straightforward, actually. Walking through all of that code, I think I'm pretty fine with most of that stuff. I don't know, what did I change here? Contents are identical. Interesting. I don't know why I have a unsaved. I commented something. Out or in? I don't know why it's not showing it to me. Oh well. That's fine. Distance between tiles we might want to use eventually. So pretty much we're going to be trying to implement this generate path. I almost want to like copy this and move it into the two things actually. I'm gonna, well, okay, first we're gonna go file JS path. We're actually gonna also go pygame test 0. We're gonna copy this and go pygame pathfind 0. It's gonna load good map 0. All of this stuff is gonna stay the same. Our goal will be to ultimately pathfind from Blinka to somewhere else on the map, and then ultimately have Blinka move along that path. Take all of this stuff out. I don't think we need that stuff. This is all stuff that's loading the map, essentially. I'm just going to kind of come down here and go def generate path. So right away we get one question. Do we want to take 4 points like that, or do we want to take 2, like 2 tuples or something? Depth first search, breadth first search, and A star are the same thing with a different data structure. I see. Okay. Different data. So it's they. If I understand you correctly, they do the second part of this the same way, but they build that. They build that dictionary, that parent first cell piece of it. Depth first uses a stack, e.g. direct recursion. Breadth first uses a FIFO queue, and A star uses the priority queue with a best first heuristic. So maybe mine is not actually, potentially not actually A star, what did I ended up with? Because I do notice I don't have the heuristic, I think, right? That it's probably what you were talking about and what this thing has as well. In which case, maybe what I have is actually just breadth first, uses the FIFO queue. That may be what I ended up with. I may have misremembered actually doing the A star. So then the A star and the heuristic, I guess, does that come into play? That's more like when I was talking about like the forest. If you wanted to have a tile that takes multiple movement points or whatever to get past it, that heuristic is like a function that helps you define that value, that cost of movement. Is that roughly about right? Generate path. I guess I'll just do the same. Part of me wants to change this to a tuple. The other part of me wants to just not mess with it too much. I do think, I guess I would be happy with like starting location and target location, like start X, start Y, and then target X, target Y. Start X, start Y, target X, target Y. They just make a queue that's a list. When I say they, I just mean the JavaScript over here, which is actually me from the past. The parent for cell is a dictionary. Could go Python style, I guess. Technically, breadth first, in case of pathfinding, is called... Ooh, I will probably butcher it, unfortunately. Dijkstra's? Dijkstra's? The J is silent, maybe? Just Dijkstra's? Dijkstra's algorithm, perhaps? Parent for cell. Dictionary. You push. And so in Python, we don't have push, but we have append. Dutch names. No idea how it's pronounced. Fair enough. Q append, and then we're appending dictionary with the target XY. At least I think that's what those are. Hopefully that's right. Otherwise, we'll have to go back and swap the names on my thing. Wouldn't be so bad. These do have to be strings in Python, though, I think. Okay. Pin that to the queue. While the queue is not empty. While length queue greater than 0. Easy enough. Should we be commenting these the same way? Probably, right? Oh, well, not literally the exact same way, I guess, but DQ. Yep. That happened. DQ. So XY is Q shift. Shift. We will have to go look that up. Shift. What does shift take? I mean, we could look it up in the docs. We could also do a little bit of experimentations there. We could go like L equals this. 1, 2, 3, 4. L dot shift gives us 1. And a 1 is gone now. So it takes the first one out of the list and returns it to you. So in Python, I mean, this would access the first one. I think you can use del to delete it. That's probably not how we want to do it, though, right? I don't know. Where? I have too many browser windows. Let's start with that. Worst case for A star is actually the same as Dijkstra's, I believe. It's just the best first heuristic of A star. Often helps you go in the right direction earlier, which speeds things up in typical situations. Okay. Nice. Yeah, thank you for the added insight here. Definitely appreciate it. Q. Oh. Well, so I don't think we have collections. Oh. Okay. That makes it pretty easy actually then. So one required positional argument. Is this not dequeuing? Popping items? Pop left? I have a feeling... So I actually didn't even know we had collections, truthfully. Need to get my bookmark of that index page. Iterable max length. Must be specified. I have a feeling I'm... Okay, double-ended queue. Right, that is not what I want, really. I want to remove a thing from the front of a list. I want to dequeue as a verb, which maybe is not actually properly a word? I thought that was a word that meant, like, remove one thing from the queue. Can you pop the beginning? Is there, like, left pop or something? Or pass an index to pop? Remove? Reverse? Oh, that looks promising. Yeah, there you go. Okay, pop 0. That would work too, yeah. Reassign, like... Yeah, reassign it with a slice. That would work as well. DQ can push pop at either end. I see. A double-ended queue can push pop at either end, which does make sense. However, I don't necessarily need that, I don't think. The list should be good. And list pop 0 should work for what we need. This is not the right place, though. So, DQ. So we were getting a point, so... const xy. Let's call this... I'm going to call this point dictionary to start with. Point dict equals q.pop 0. And then I guess we'll want to... I mean, we should already have that, right? Where's neighbors? Yeah, these are XY dictionaries. This feels redundant to me, right? It's like taking them out of the dictionary, spreading them into these two variables, x and y, and then turning around and putting them right back into the dictionary here. I mean, a different dictionary, but Python calls pop front, pop left, I think. Ah, interesting. Pop 0 seems to be, at least in CircuitPython. I do not know. Hopefully it's the same in regular Python. Yeah, it does seem to work the same. Pop, you can pass an index to, it looks like. Ah, I see. DQ data structure makes pop left efficient, I see. Let's see here. And this does feel the same to me. Current key. I almost do want to do more than that. Pop 0 on an array has to move all the other elements, though. It's not that it matters if the array is small. I see. The double-ended one will be more efficient, potentially. I will keep it in mind. I do expect mine is going to end up being pretty small all the time, because in my target, the thing I hope to use this for, it will be relatively small maps like this. And the characters will have a limited movement range as well, so they won't be able to go too far. I think my queue will stay small. If I do run into trouble, I will probably, that'll be one place that I will try to squeeze out some more efficiency by using the DQ, the double-ended queue. That is good to know for sure. Current key is the string one. We're going to do an F string, and it's actually pretty close, so I have chosen to keep this as a dictionary, which means we're going to do this like that. Current key into there. Current. So see, current here is basically this, right? Current is an XY object in JavaScript, dictionary in Python, that has X and Y with values, which is exactly what's already inside of Q. The first one got pushed right here, and it's the exact same kind of thing. That is weird. Yeah, I needed to do that for some reason. Is there a problem with just reusing that dictionary? Point dick? I'm just gonna try it like that. Get the neighbors. I did it again. Neighbors is a list. Of these XY dictionaries. Okay. So I will say, actually, yeah, X and Y here would be kind of handy. It would make this code less verbose in here, because this is going to have to access pointdict.xy a bunch of times like these ones. So maybe it does make sense. You take them out of there. Can you set two things like this? Is that valid? It doesn't like the names, I think, but oh. X from the outer. Oh. Tricky. Yeah, we already have a bunch of X and Y stuff. All right, we're gonna call that point X, point Y. And then we need actually -1 for one of these, and we'll basically do the -1 in a different location for all of these. Oh, and we'll have +1s as well. Okay. Have a list of neighbors for each neighbor. I cannot believe it. This is looping over neighbors, so we could actually just go for in neighbors in X equals neighbor X, Y equals neighbor Y. Ignore tiles outside the map. the map. What is the map? Map object. Oh, this does not actually use the... Does it? This does not actually use the tiled game helper. Okay, wow, this is like a very, very early version. This one's not using this object. Should we try? Actually, probably gets rid of a lot of our code in here. Fix a map.json file, which it will open and load. Let's try it. I feel like it returns more of a game object. I don't know if this will work. If it doesn't, then I'll probably come back to just doing it the way we started. Which essentially, like, a lot of this code is inside of that object. Does that stuff for you. It has the idea of the cursor in it as well. You know, we're gonna go Pathfind 1. We're gonna take a fork in the road here. We're gonna make this easy to get back to. Okay. Okay. You can always go back to that. But in this side, we'll try this one. I think we actually just don't need any of that. I have no idea if that transparent will be messed up. I don't have those objects anymore, so. All of this stuff is inside the game object now, if we use this helper. And then game object extends group, so we can just go main group, append game object. The scale is messed up, but everything else is working. Did I just do scale 2 before? Something like that? I mean, we could do it here. There we go. Perfect. Okay, back to the exact same place we were, but the majority of that code is now not in our script, but in our helper object, which actually I created a while back. I thought we were already using that, but it turns out we weren't. This was an even earlier version. Essentially, the code that went on to become that helper object is what we started with. But now we got it. We have a game object. This is going to be helpful because the game object has a width, I think. We can easily find the size from this. Is what we need to actually fill into that if statement. I think. Map object. Is tile movable? Get tile. Ooh. I mean map object, I guess? Thought we would have a width. I mean, we have a width of the group. That's not what we want, though. Have all the tile grids, which I guess technically we could do. Let's look at map object, I guess. Map object. It's basically printed a lot of the same stuff. It does have height, so it should have width as well. Not actually JSON, because it's single quotes. It does have height. Probably is width somewhere as well. Width is down there, yeah. If it's greater than... You'd actually want -1, I think, right? Because the last index that's available is one less. Yeah. So our version of that bit is game object, map object, width -1. Basically, the height, same thing for the height. More tiles that can't be walked on. Conveniently, we actually do have can walk, or, well, we have is tile movable, which is equivalent to can walk. Tile coordinates. Tile coordinates as a tuple, or dictionary with XY. Perfect, actually. It's even better. This would be neighbor X, neighbor Y, which I guess would be neighbor, right? Neighbor is the dictionary. We're looping here. This one's recreating a new dictionary, but neighbor already has that stuff in it. We can just use that. So this is actually really nice because this will use Kenwalk. This will use these things. Anything that has Kenwalk unchecked, you're not allowed to walk on that tile. So the robot here, Adabot, you won't be allowed to walk on that. Ohm, you're not allowed to walk on in this case, but the heart you would be. So if we had a heart here, you'd be able to walk over it. And I think that's already just hooked up. I believe this is tile movable, works with that check mark there, so kind of convenient if that actually does all work out. This is the key that represents the neighbor. So this is the X, the string with the X separating that points to the neighbor, which we do not have yet. So I'm gonna call it neighbor key. If not discovered. Are you targeting some MCU? Yes, I will. Well, so ultimately, ultimately, the goal is a not quite custom piece of hardware, but hobbled together piece of hardware. I don't have it here on my desk anymore to show. In a previous stream a few days back, I think on Monday night is when I streamed this, I worked on connecting a barcode scanner to a microcontroller, and I talked a little bit about my overarching idea with this, which is, I'll recap very, very briefly right now. My goal ultimately is to make a kind of knockoff version of this old scanners with a Z handheld device made by Radica, which basically was like a Pokemon knockoff, with the gimmick being that you scan barcodes to find new Pokemon, or whatever they're called, and other stuff. I am ultimately in the end goal aiming for a game that's like this. However, unlike Pokemon, Pokemon pretty much has like what I'll call kind of like rock, paper, scissors battle, where it's like two things fighting and you just take turns using actions. The battle will be a two-dimensional field like this. You'll be able to move around and take actions. So there will be like a location layer added on top of the basic Pokemon battle system. So eventually I will make a little handset like this that has the barcode scanner in it, that has the display, that has some kind of microcontroller as a brain, that has some kind of buttons as inputs. That is like ultimate goal down the road. The intermediary goal would be this Pi Gamer. So this Pi Gamer here ultimately will make a stop off on this, which this is basically, it won't have all the barcode scanning stuff. But once I get the pathfinding working, I will run it and test it on this thing some. And I think if I just restart the code that's on it, it should go back to at least drawing one of these maps. Yeah, so it's got the same kind of map on there. So we'll stop off there. We'll do some bits there, and I may end up making, more games that make use of this pathfinding algorithm. This idea of these top-down 2D sort of tactical battle games, I'm pretty drawn to these types of games and tinkering with them. So this gives me a good like sandbox to just play with these things. I'll probably end up making a bunch that never see the light of day, but I tinker with and have fun with on my own. Good morning, DJ Devin. How's it going? Let's see here. Let me remember something like that was around in the 90s. Yeah, this so Radica scanners, this one was in the mid 2000s. It was like 2000 and maybe even 2000, maybe mid to early 2000s. Doesn't have a date. 2001. Scanners command released in 2000. Looks like the original ones maybe came out in 2000, and then they released the like better one that had all the stuff inside of it. When they released it, it was like Pokemon, where they released different colors, and you had to have a certain color to get certain stuff. And then they eventually released a wild card one that had all the stuff. I say eventually, it looks like it was the next year, so they didn't wait too long. But yeah, they are definitely very strange looking. And from what I understand, the barcode scanner was not that great. It's kind of fiddly, and you got to point it just right, and you got to swipe it across the barcode just right. Whereas the one I've got is much more like a modern checkout system, where it kind of just boops and finds it real fast. It's actually based on a camera, not like a laser or a 1D thing. In the 90s, what I will say though is like Tamagotchis and virtual pets and things. This was essentially kind of just a next step in that line somewhere of like virtual pets and Tamagotchis and things of that nature. And those were definitely 90s things. Barcode scanners are horrible in general. Some of them. I mean, there's good barcode scanners out there. I don't think they ever became too popular here, but I remember seeing some ads as a child. Yeah, I totally missed this when it came around the first time. I don't remember this thing existing at all. I found it recently on YouTube, the YouTube rabbit hole. They also had a what? Interesting. Okay, they also had a race car themed one instead of monsters battling or whatever. This one you got cars, and I guess the cars probably had different stats and things for speed and all that stuff. Affordable barcode scanners. Yeah. Yeah, I mean, it depends on your range of affordable. I feel like the one I got is not necessarily outside the range of affordable, and it's actually pretty snappy. But it is, I mean, it's not cheap per se. It was $50, the barcode scanner component, so like, I would not call it cheap, but I would say it's affordable. This totally depends though, right? This depends on your situation a lot. If key is so if it's not discovered, so basically we're throwing out ones that are discovered. So if key is in parent for cell, which we do have parent for cell. Yeah. Key, but we don't have key. We called it, I didn't call it key, I called it something more specific. I think neighbor key, right? Mark it as discovered. So if we made it to here, we're going to mark it as discovered. Key. Mark it as discovered, i.e. put it in this dictionary of parent for cell. Key. Current key. Current cell, but our current cell was just point dict, I think. I'm pretty sure that's gonna already be the right thing. If not, then we'll come back and make a current, but I think this is already, would have the stuff we need already. Market as discovered, add it to the queue. Oops. Portable bark, yeah. They won't put very high-end stuff in those toys. That's true, yeah. Yeah, and I do think my final handset will end up being much more expensive than you could actually market it as a toy, right? I don't think it would be a successful toy at the price point that mine will cost. Even if you weren't just making one, which I plan on making one basically, at least to start with, even if you were making dozens or hundreds, it still probably would not get down to a price point that's like feasible with the hardware that I intend to use on it. I think the truth is, like, as a piece of hardware, it probably doesn't, there's probably not a big enough market to make it profitable, I would guess. Like, the truth is, like, this is a phone game, truthfully, more than a handheld game. I'm interested in making it into a handheld for the novelty factor and just as an exercise in CircuitPython, and just because I think it's cool to have it on a separate thing. Realistically, though, if there was a company that was thinking about making this thing, it probably would just be a mobile game. Maybe they could add some kind of toys as components that it scans, but they probably would go that route rather than the handheld like I am. For that reason, right? The phone is already better than most barcode scanners that you can get for cheap. The phone is going to do a way better job. I do like the one I got, though. We don't have push, we have append. It says neighbor's eye. Ours is just neighbor, though. One thing I don't understand. So that ends the neighbor. Why has nobody come up with a good game controller that attaches to a phone? We could do away with horrible touchscreen. It's a good question. There were some that seemed not bad. I think the problem is that phones, there's too many shapes and sizes of phones. You either have to target one specific phone, which means you have to target like the most recent iPhone, because that is, like, if we're talking about specific models of phone, that is certainly the single model with the most people out there, probably, so the largest market. But that's tough to sell a piece of hardware that is an add-on that only fits one phone. So then you have to try to, like, somehow it's adaptable or whatever to try to make it fit multiple, but, you know, you could probably get there all right, and it would be all right, but then it gets clunky, kind of. It doesn't fit. It fits more devices, but it doesn't fit any of them well, necessarily. Wireless doesn't work because then you run out of hands. Yeah, there have been a handful of ones I've seen, but none that were like... I don't even remember the name. I actually worked on software that was used to demo one of these things in a store several years back. I do not remember the name of the one. Something like that, maybe. Just an add-on to the controller. Yeah, I don't know. I think you're right, though. There's definitely there's a gap there. There could be a cool thing that kind of turns phones into little gaming machines even more than they already are. All right, so after those two loops, but we're still inside of generate path. Here we're printing parent for cell. I guess we can do the same thing. Path is a list. I say current key. They have current key already, I guess. And it may not have changed. I don't know. Another one of these. There's our underscore X, which are the current, the starting location. Starting X, starting Y. Whoops. How's it going, Marengo? Thanks for tuning in. Hope you're having a nice day. Happy holidays if you are celebrating the holidays. Let's see here. Appreciate the follow. Marengo. Yeah, appreciate that, friend. Pretty nice, thank you. So the algorithm spirally looks at cells surrounding the starting location. Marking those cells as being adjacent to the cell that's ultimately adjacent to the start cell is the final path optimized to be the shortest path. Good questions. I think you are on the right track. I do think it might be backwards. I think it starts with the target. So I think it's actually going to spiral outward from the target and then find the starting point eventually. Will it be optimized to be the shortest path? I do not know. I do not know. I think so, but I do not know. Could you explain exactly what you're doing? Sort of. I can, so the truth is, like, some of the actual, like, fundamental math, I cannot necessarily explain that part of it, because I followed closely along with the tutorial and understood it only enough to write the code the first time I did it over here. Correctly done breadth first will find the shortest path. Yes, okay, there we go. Thank you. Appreciate that, Maestran. So if we do it correctly, then we will get the shortest path. What I am doing though, for, is it Marengo? Hopefully I'm announcing that, pronouncing that, at least close to correct. So I am implementing a pathfinding algorithm. Ultimately, this pathfinding algorithm is going to run on a, wrong browser again, is going to run on a microcontroller like this one, little handheld gaming device. This runs CircuitPython. So I don't know if you've seen any of my prior streams or not, but CircuitPython is what I'm usually working with. We're writing a pathfinding algorithm that's essentially going to let you take one of these characters, and it's an algorithm that will find, how do I move a character from one location to another location, accounting for the fact that certain tiles might be impassable. So like, let's say we're trying to move Blinka, the snake here, and let's say we're trying to move it here. But let's say we're not allowed to walk through Adabot, so we would not want to go right and then down to get there. We wouldn't be able to do that. We would need to come down and across, or maybe we could go over and then down and then across, but we can't pass through Adabot. So we are writing the algorithm that finds that path for us, that list of tiles that we can move through to get to the target cell. And then even more specifically, I should say, we're not necessarily writing it just from scratch. I am actually converting an old implementation I made in JavaScript over to Python to output into display.io. The JavaScript one outputted to Phaser game framework. You can search in either direction. Just starting from the target has the advantage that you can search for closest of multiple targets at the same time. I see. Okay. So you can start on either. I think that my implementation, if I'm understanding it correctly, is starting on the target. I'll be back in 1 second. What are we getting into? Let's leave that alone. I guess I've seen something like that using different algorithms. There's a web app that lets you draw the obstacles and it finds the shortest path. Nice. Yeah, that is essentially the algorithm, the same type of algorithm we are implementing. First thing that comes to mind is PCB auto routing algorithm for a one-layer PCB. So something like this does have, oh yeah, for sure. Yeah, lots of real-world applications. I mean, you could generalize this. You could generalize this into lots of real-world problems. I'm sure realistically, things like finding routes for trucks, right? Like trucks are a certain height, a certain amount of feet tall or whatever. And bridges are also a certain height. And when a truck tries to pass under a bridge that is not tall enough, it's a bad time for everyone involved. So you could essentially use like city grids, like actual grids of streets as your grid. You could be pathfinding your way for a truck to say like, my truck is 14 feet tall, so find me a route from point A to point B that doesn't pass under any bridges that are too short. That would be another like potential real world thing. Application for this kind of general problem solving algorithm, or for this kind of algorithm. It doesn't solve general problems, but that is the kind of problem that it does solve. Okay, they're saying current cell, which is current cell. It's basically actually just the starting locations, but as an object. Oops. Good application for server security when routing. You probably want sensitive data stored in further servers so you know what to avoid. You could do that if you're hopping data from different nodes of a network or something. PC auto routing is a harder problem. I believe that. Let's see, pair for cell. 3D dimensions make things, oh, for sure, yeah. In the third dimension, UPS has amazingly efficient algorithms. I would believe that. Sure. You got to. It's like that's a tough. Logistics is a tough nut for sure. Tough nut to crack. Print cell, so it's printing that. Generate the path with connecting cells. We don't really need starting to generate path, I don't think. We do need a way to compare the 2 points though. So this is where we used Lodash. Can you just compare dictionaries, or how does that work? I mean, I think we probably just write a function that compares points. If this doesn't work. Okay, so far so good actually. What about like this though, right? Does this throw it off? I think this was part of the problem that the JavaScript one was solving. Okay, that should be fine. I think that should work. So we're saying while not equals the current cell not equals this object, which is x1, y1, which for us was target. These ones we did here, so target x. So while current cell is not equal to, I almost want to have like target cell. Have target x, target y. I mean, surely it's better to create that dictionary once and compare it than to create it every time, right? Oh, speaking of which, let's not do it inside the while loop. Target cell. Oh, we appended it to the queue. I guess maybe we could have done that. I don't know. Let's do it this way. All right, target cell. Current cell. While current cell does not equal target cell, is what this says. We have print the path length. Let me catch up a bit. I think the optimal solution is probably NP hard. Probably not that hard. You can simplify 3D to 2D and add the third dimension as a constraint, but locally, all you need is height data of every bridge. All the usual search algorithms work with arbitrary graphs. They don't care about the dimensions. But searching for the shortest path is straightforward. Searching for a set of paths that doesn't conflict is a lot harder. Okay. 30 protocols for network. Talking about professional WANs and ISPs, not like home setups to the ISP. Built for BGP edge routers, specialized in devices with specialized devices and protocols. So we go print the length, and then we'll play with this. I guess I'll do this for now. If length of path is greater than 4, just return false, which basically means we failed to move, right? This is probably we would not want this inside the path algorithm, truthfully. I think ultimately we would probably the path algorithm should just generate the path between the two, and then we'd have some other logic that determines if it's too long, basically. I guess this allows us to bail early, which is convenient. Yeah, so it's more efficient because we don't have to check anymore once we return false here. Whereas the other way, this would have to generate the whole thing, and then afterwards we'd check the path and be like, oh, the path is actually length 10, so it's too long, but we actually did this bunch of work in this loop. What keyboard you got? I have a Kinesis Advantage 1, the black one. I have the official keyboard of the Men in Black. This is my keyboard. And for setup, if you mean the rest of the stuff about my computer, it is a System 76 desktop computer. They sell pre-built Linux computers. They make Pop! OS, which is a Linux OS. I used that on my last computer. I thought it was all right. This time around, I just got this computer a couple of months back, this new desktop. This time around, I went with Ubuntu instead of Pop! OS because I was hoping that I would not have to customize as much stuff, and that some stuff would work a little bit more easily than it did on Pop! OS. Truth be told, there's kind of the exact same amount of stuff that has to be done. There are a few upsides, there are a few downsides. There are lots of the same things that still need to be customized. And it has a lot of RAM and a fast CPU. There's no parent, so undefined is going to be a different kind of thing. Is it actually doing what I thought, which was basically checking if that thing was not in the dictionary yet? Thank you, Mendes. If that's actually what it's doing, then I think that's easy enough to write using in. But is that actually what it's doing? Undefined, yeah, okay. So you can access whatever you want. You don't get a key error. None of this silly key error nonsense in JavaScript, no. You access it, but you get undefined. And so here we'll just say, if it's not in that, if no parent, then we don't have a path. And the if is if current key not in. I think you can just leave it like that, but I'm not positive. And a lot of times I write it like this, keys. So I'm certain that this works. And I'm less certain that it works if you leave off keys. I think maybe it does. So if that's not in there, then we just return false. Python false though, not JavaScript false. Else we go path.append current cell. Const. This is creating key and cell from parent. I don't think we need to create these, right? This is basically just taking them out of here and putting them into here for the next iteration through the loop. What about mouse? My mouse, I don't actually know the name of my mouse. It's a vertical mouse that I got off of Amazon. I don't even see like a name on it, truthfully. It looks vaguely like a shark fin. Sometimes I call it a shark fin mouse. It is like these. Then we did not pass by the specific one. I don't actually know the specific one, but it's kind of like these. It's pretty much the same idea as these vertical style ones. Is the Kinesis good? I think the Kinesis is good, yeah. I think it took a little while to get used to, coming from a regular keyboard, but it is way better than a regular keyboard for a few reasons. I think the split keys definitely better than a regular keyboard. The other thing that I think is better is the vertical lines being straight. I never like realized how messed up regular keyboards were until I started using this one. But like the C key, for instance, the C key you're supposed to use your middle finger on, but regular keyboards, it's all like a mile to the wrong direction, right? You have to like, you can't really use your middle finger. But you're supposed to, supposedly. This one, because they're in straight lines vertically, it's like perfectly lined up for each finger. The cuppiness of the things here helps with that as well, but even just the vertical lines like is a huge improvement, I think. I do have, I must say thank you to my beautiful wife for all of my ergonomic leaning devices. That is where that habit came from. But yes, I do have the keyboard and the mouse, both of which she used before I did. And professed the virtues of to me. I agree. And here I am, professing the virtues of them to you. So try out a Kinesis. Yeah, that's the thing, right? It's crazy. Like the C, it's so far over to the side, but it's like supposed to be a middle finger key instead of a first finger key. And so like that's one of the things that it took a while to get used to when I did switch. I won't say that it was like super easy to switch. I mean, it's not like hard. It just took, you type the wrong thing, right? Every now and then you typo when you first get going with it. But like that was one of the ones that I typoed for a long time, was accidentally using the wrong finger on C because of that. If only I could get one. They don't even sell in Brazil. I gotcha. Maybe check if eBay will ship to there. Honestly, mine and all the ones I know of came from eBay. I will say they're on the pricier side for a keyboard, though. Although keyboards have gotten pricey in general. You could certainly spend more on a keyboard these days. The iteration parameter puts a cost how far an object can move, giving the other pieces the opportunity to reposition. Past him has good ideas. Yeah, well, I think the iteration parameter, You mean back on this one? So this one is putting the limit. This one here, I should say, is putting the limit on how far they can move, I think. But that is totally the idea, is like the different units, units will be able to move, and then they'll have a certain movement. Each one will be like, this one's allowed to move 2, and that one's allowed to move 6, or whatever, right? They'll have different speeds that they can move, essentially, different amounts of tiles in one turn. Had a vertical mouse once. Turns out I'm quite comfortable with my non-vertical with 12 buttons on the side. Nice. Yeah, hotkeys are a big thing. Another thing that I did use a whole lot, I have actually kind of weaned myself off a bit, and I actually just use the keyboard a lot more now. But I actually did use this thing for a long time with hotkeys on it. It's not, I used it on the other side, not the mouse hand, but the other hand. And it's just like can have layer of hotkeys inside of it. Well, it can have multiple layers of hotkeys inside of it. My mouse does have a couple of buttons extra. It's got like, I guess 2 extra buttons. It's got 2 thumb buttons, which I do not use. However, my wife does. She uses them for copy paste. One of those wow macro mice. Always kind of wanted one. Thought it had just too many buttons. Continually clicking the wrong ones. If they're positioned well, it can work. I rarely do. Most use 6 and 3 for media control. Play pause. Play pause would be super sweet to have on the mouse. And volume as well. That would be pretty sweet, actually. I would like that. Apple Expose, show desktop. I gotcha. It's like a screencasting thing. Yeah. 1.5 minimum wage salaries for the Kinesis. Yeah, they are not cheap keyboards. They are definitely pricey. A couple $100. Easy. Even used, they hold their value pretty well. Even the used ones on eBay tend to be still a couple $100. The thing for me though, like I ended up thinking that it made sense to invest in, because I used my keyboard like kind of all day every day. Like I use it for my full-time job. I use it for, now my part-time job working on CircuitPython on Mondays, like is on the computer using my computer, right? I use this keyboard essentially all the time. When I'm at the computer, which is like every work day for a huge portion of the day, plus a decent chunk of my leisure time happens to be on the computer, right? Video games and things like this. A lot of that occurs on the computer as well. So it's like I use it a lot, and I think eventually, like, my body will wear down, right? Like, don't get it twisted. Software developer is not that strenuous on the body, but like everything is strenuous on the body. So doing the same thing over and over is strenuous, even if that thing is not particularly damaging or strenuous in and of itself. So I try to get everything like really nice. I really invested in the keyboard and the mouse. I actually just got a new chair as well, which is a relatively pricey chair. But it was for the same kind of thing. I was like, I'm investing in this thing. I'm willing to spend a good chunk of money, a month or whatever of salary into a nice chair because I'm sitting in it a lot, and it's like better for my back and all sorts of stuff. So, and I'm liking the chair as well. I forget the name of it. It's a Herman Miller office chair though. It's like a higher end office chair, but it's like super duper comfy in all the right places for me. I tried it out and it was like, let's see here. Has lots of adjustments and stuff as well. It's kind of, it's really along that same path of all the ergonomic stuff. It's like an ergonomic chair with lots of different adjustments for how you want the angle of the seat, how far back you want it to be able to lean, how easy it is to lean versus hard. It has an extra little support thing in your lower back. I think my desktop keyboard is 10 to 15 years old. Have I used an MX keys? Do you mean Cherry MX? Is that a different thing? Do you mean Cherry MX? Logitech MX keys? Is this what you're asking about? Not actually sure. Logitech, okay. I have not tried it. I will say right away, it's like tough for me to ever want to go back to a non, they call it ortholinear, but with these things not being straight. I feel like I'm like learning how to walk for the first time again every time I go back to a keyboard that's not ortholinear. It's interesting. I will say I want to feel its keys. I don't think I could use it as a daily driver because of that. I think I'm like wrecked on the ortholinear at this point. I pretty much have to have that. You know what I do like the look of as a tactile touch is the way it looks like there's a little impression in each key. You know, a little finger divot. I really want to press them. I really want to see how those little divots feel. Yeah, I had not seen this though. USB-C rechargeable. Interesting. Hype, but they look good. My mechanical keyboard is from back when mechanical keyboards were still super nerdy. Ultimate with MX Blues. This thing's lasts forever. The is it blues? I think mine's, is it browns? I think mine has browns in it. My Kinesis, I think, has browns. The mouse is awesome. I'll have to check out the mouse. My keyboard, the media keys are on the right side, so right hand, therefore having them on the mouse makes sense. I have media keys like play, pause, volume on the keyboard. Headset has volume and muting. Putting that on the mouse would be overkill. Yeah, if you already have access to it, that does make total sense. Not anymore. Brings up a good point. Most of my time spent with only one hand on the keyboard, one on the mouse. Yeah. Yeah, the Nostromo pad was my answer to that for a long time, where I would go one hand on the mouse, one hand on the Nostromo, and I had a bunch of hotkeys over there. And then I would only move back to the keyboard for like typing. But I even used like copy paste on the Nostromo a lot as well. So lots of coding is not necessarily typing QWERTY. So mouse does seem inefficient for browsing and gaming. For coding, do you like the impressions in there? Yeah. Be interested in at least touching one. Yeah, totally. Hopefully they have them on. I try to get myself into Micro Center on a relatively frequent occasion. Hopefully they'll have one there and on display. Putting together a Nyquist NeoKey 5x6 for my work computer. Oh, nice. Nyquist. Is that a Nyquist? Is that a Nyquist keyboard? Ah, there you go. Okay, nice. You got the split square look going, a rectangle, I guess. Yeah, I like it though. I mean, that's the same idea with the ortholinear going there. I'd be curious to try this actually. I have no idea how much the curviness of the Kinesis is what is like part of what I like or not. I'd be curious to try this because it's all flat, but it's still ortholinear. That looks pretty sweet though. Just wish I could get a laptop with ortho. Yeah, totally agreed. Looks like JP's, yeah. JP's from the, yeah, with the matrix of keys. Okay. I think we're close here. I'm going to try to see if I can run this. I'll probably be wrapping up before too long here. I would love to have this run once, though, and actually spit us out a path in current cell. So really all we did there then is just we printed the path and then we returned the path, which is just a list of points, essentially. So let's say print, and it's gonna double print. I guess we don't really need this. Let's take that out. Let's just go print, generate path, and I'm just gonna hard code right now. Like we could probably, there should be an object for like player XY or something. There should be a way to like, I think get Blinka specifically. I'm not even gonna worry about that though. I'm just gonna say 0, 0 for our start X. Generate path 0, 0. Go from 0, 0, and then I am going to use the AdaBot here to test out. Now, you know what? Let's go even easier, honestly. Let's start nice and easy, super duper easy. Let's just go right here, 2 to the right. So 0, 0, and then 1 and 2. So 2, 0. 2, 0. 0, 0 to 2, 0. And so our path should be 0, 0, then 1, 0, then 2, 0. That should be our path. And it's not actually going to move, it's just going to print. But that should be what it prints if everything works. False. Okay, everything did not work. Our path length seemed to grow. Too big, and then eventually we returned false, which would have been because the length was too big. So let's actually be printing path inside of here. And we might need to turn off this for now. Oh, okay, so we are getting 0, 0 over and over again. Okay. Because I don't like moving my hands a lot, so it's hard to justify a macro keyboard. Yeah. Foot pedals. Yep. Foot pedals are untapped potential. I need to get into some foot pedals as well. If your cells panelized, I don't know if they come as kit, but almost identical to the Nyquist. Usually sit in a tall bar stool and at a tall worktop bench. Foot pedals sound cool. Ah, wouldn't be able to touch them too far, yeah. So our path, I mean, probably if we got rid of this, it goes infinite, right? Like, let's be realistic. Most likely if we don't do this, it's just going to go infinite. And just keep adding 0, 0. Yeah, see, we're just to the thousands. We're just continually adding 0, 0 over and over. So the things we're adding to path are wrong. So let's start there and work backwards. So, well, let's also go print parent for cell. For cell, if that's right. Okay, parent for cell is this. It's got 1, 0. One zero is the key here, and then it's got the 2, 0 there, and the 2, 0. 3, 0 was from 2, 0, 1, 0. Seven, 0. Okay. Seems kind of okay. My loop messed up? Touch foot pedals to the footrest. Conga bongos on the stool. Currently using blues. Blues feel better for typing. Yeah, they are more loud. The current cell. Current for cell, current key. Current for current key is this. The current key is 0, 0. Which is where we started. Makes sense. The parent for that is this. which is 1, 0, which makes sense because I think we started at our target and we moved backwards to get to our beginning, which means the parent for our beginning is actually that first step that we would take here. That seems okay, but then once we go and add it to the path, we add 0, 0 the first time, and then the next time we should actually add 1, 0, but for whatever reason we keep adding 0, 0. The path starts empty. While current cell is not the target cell. Path is too long, we ignore it. If there's no parent, then we don't have a path, therefore we ignore it. Otherwise, we append current cell. Current cell... Okay, I see the problem, I think. So current cell, we append current cell, but current cell is always start X and start Y. And in this one, it actually changes. We need to change current key and current cell to the next iterations. These ones are always staying on start. So they should actually be what we get out of parent. Parent object is that. And then current key should be parent object key. Current cell should be parent object cell. Then this loops and checks again. Okay. Yes. Maybe. Path length 1. So we move from 0, 0 to 1, 0. We need our 2, 0 actually, though. Our path, I guess, does not include our target cell. Should we append the target? I think maybe we should append the target cell. Keys. Joysticks and levers. Get rid of rotary encoder for a joystick. The joystick being pretty handy. Okay, so let's try it a bit more. And I do, like I said, I do think I'm close to wrapping up probably for the day, and I think we're there at this point. I was expecting it to include 2, 0. But it looks like the way it works is you get the path up to. You get the path up to your target. If you wanted to include your target, it looks like you would need to append it specifically. So if we wanted to actually illustrate this now, we could go like, how could we, is that going to be easy? I don't actually know if that's going to be easy. It would be entities, update player location. Sounds promising. For location in path. For location in path. I'm sleep, first of all. Well, last of all, I guess we're going to do it afterwards, but I'm going to code it first. So for each one, we're going to set the current location. So game object, update player location. Oh, no, that's wrong. Player lock. I don't know if it gets changed actually though. We have a ton of extra prints now. How come that never printed? Player lock. It did, but it's 1-1. Oh, it's supposed to be 1-1. Oh. Oh. Okay, part of our problem, I guess, is we're not starting in the right spot, maybe. Object dot player lock equals lock a player lock time sleep error. I gone and broken everything. I don't think I'm going to make it to actually showing it move. I'm running out of steam for the morning, I think. I was offset by 1, so our character is actually on 1-1, but now it's broken. Now our path is not generating right anymore. Our path from 0-0 seemed to be okay. For these index. What? Can I see the path? How do we... E. These are all still having zeros. None of these should be zeros anymore, I don't think. I mean, 3, 1, I guess. Like it's not starting in the right place or something. Well, okay, the neighbors, I guess, would still be 0. Some of the neighbors, I guess, could still be 0. We're not getting the right stuff in here, I guess, though. Why do we not have 1, 1? I don't know. I mean, this has mostly zeros. We should have a few, but really only like 1, right? We're only doing the 4 neighbors. So if we're starting on 1, 1, we should have 1, 0, and we should have 0, 1. And then I guess if we move this way, then we could have more neighbors that are zeros, I suppose. I suppose that's true. I'm a bit bummed that it doesn't work better, truthfully. I thought we were there, but the 0, 0, 1, 1, it seems like we have probably, I guess, an off by 1 error somewhere. The 0, 0, 1 looked fine. I gave it such an easy one, though, right? We didn't even try, like, moving vertically or anything, so... So in our case, we never really end up outside the map because we actually have this layer of walls. This is backwards. Isn't it? I think this is backwards. Yeah, this is backwards. Is tile movable returns true if you are allowed to walk on the tile? This needs to be if not. See doodles. Yeah, I think that one might have worked, although it was probably like so fast I didn't really see it happen. Let's go wait for 2 seconds and then do the move. And it does look like it does not include... right. Yeah. Okay, so the problem is we haven't refreshed. Hmm. Yeah. I don't want to do this kind of logic right now. Problem is our screen does not refresh while we are sleeping. This is actually one of the spots where we are getting into trouble by using the Blinka and running it on the PC. If we were running this on the microcontroller, we wouldn't have this problem. Here's what we're gonna do, even though it doesn't make really that much sense. Can I just refresh? Refresh once there, refresh once each time through here. Okay. Our path, I mean, should we handle it outside of our algorithm? I kind of want the last place in our path to be the target location. Target cell, in fact. Should I do that outside the algorithm? Is it bad to do it in here? Okay, so wait 2 seconds. There we go. And it moves to there. So obviously that one is relatively easy, low level. Let's try down one as well. Oh, interesting. Okay, it chose to go down and then over. Did it go diagonal? It sure seemed like it went diagonal. Sleep less there. Yeah. Interesting. I did not think diagonal movements would be allowed, and it makes me question whether we actually got that. Oh, I see the problem. These should not be here. Okay, that is more like what I was expecting, although I was thinking over and then down, but down and then over is the same difference, basically. That is more like what I was expecting. So the real test now, though, is with the AdaBot. So let's say we go the one below the AdaBot. So that is, this is 3.2, so 3.3 is AdaBot, 3.4 is the one below that. So in this case, we will need to go around AdaBot. Probably, I guess we'll just go down first and then over. Yeah. But to really show like what the algorithm is doing more specifically, let's change it up. Let's make Blinka start on one side of Adabot, and then we'll move to the other side, which means Blinka will have to go over and around, essentially. And then I'll probably wrap it up after that, because I do think we're there. Let me get rid of heart. I don't know how to select. It works. Does it? I guess it doesn't actually. Well, I need to deselect now. I don't know how to deselect. I can. It's not placing it, and I think the reason why is because it's not inside the selection. There we go. Okay. And then, so this time we will also do, instead of 1, 1, and also we're starting at 3, 4. I maybe should have put Blinka on the top, but whatever. We're going to be going to 3, 2. We're not going to be starting at 1, 1. In fact, we're going to go player lock X, player lock Y. Sweet. Perfect. Okay. I think that is gonna do it for the day. That is basically what I wanted to do, and we made it there. Glad that I persevered. I was gonna give up a little bit ago, but we made it. So obviously there's a lot more to do for the grand vision, but this one piece of it I wanted to do today was generating these paths of movement from one place to another. So I will go on to implement that, or integrate it, I should say, into the larger picture of the game later on. Thank you, everybody, for watching. We do have a couple of folks on Twitch. I'll see if there's anybody we want to raid, maybe. See much in software. Social platform. Anybody doing Python type stuff? Dev Python? German language? Only the one Python. Admin of code. All right. I don't see anybody doing any kind of Python or anything. If anybody is in the Twitch chat and knows of a Twitch streamer who's on right now that you like and you think this audience would like, let me know. I'll hang out for just another 30 seconds or a minute or something to let the delay catch up. But if anybody knows of one, I'll raid over. Otherwise, we'll just call it here. Thanks for the stream. Harvested a couple nuggets. Nice. Yeah, appreciate you all watching. I do hope everybody has a good day. Hope you enjoy the rest of your day. Hope you enjoy your holidays, of course. Merry Christmas to anyone celebrating Christmas. Hope everyone does have a good weekend regardless, and all that fun stuff. Hope you have a nice time with your families and loved ones and friends, all those things. Eat yummy food, all that kind of stuff. So, alrighty. Don't see anything in the chat there, so we'll just call it for now. Go with no raid. So thanks everybody for watching. I will catch you next time. Should be still another stream this year. Friday, I should be on for deep dive on Friday, as far as I know. So that'll be the next time scheduled at least. So I'll catch you then, if not sooner. See ya. Thanks, everybody.